Good morning. Today we begin Unit 4, which has a lot to do with polynomials. Okay, adding, subtracting, multiplying, and yes, dividing. We'll do factoring. We'll do solving equations with factoring. We'll do rewriting different polynomials based on their attributes. We'll be looking at polynomials and their degrees. All the stuff we'll talk about here in this next unit. Next unit will last us about 3.5 weeks or so. Okay, we're going to start today. We're going to start with some basic things. You've definitely done these 3 basic things in Algebra 1. Okay, so today is mostly just a review. Adding, subtracting, and multiplying polynomials, right? But just as a review, let's make sure we know what each one of these words mean. Pretty sure you know what those 3 words mean. I don't know about this one. We can break it into its parts, right? Poly and nomials, okay? Poly means, yes, many, okay? Nomials, do you know what nomials means? Nomials means numbers or terms. So together it means many numbers or terms, okay? There's monomials, which is 1 number or terms. There's binomials, which is 2 numbers or terms. And there's trinomials, which is, yes, 3 numbers or terms, okay? And then usually after trinomials, we just call the rest of them polynomials. There are some specific words, but we usually don't need to worry about those, okay? We're going to start with adding, subtracting, multiplying polynomials today, though, okay? Just start off real basic at the beginning of the unit. So let's look at these problems that I have written down for you. The first problem says x to the third plus x to the third. When we are adding like basis, first of all, we can only add these terms if they have the same exponent, okay? These do happen to have the same exponent, and remember that they also have a 1 in front of them. If we add 1x to the third plus 1x to the third, we get 2x to the third. We just add the coefficients, we leave the exponent alone, okay? Now, what about something like this? 2x squared plus 5x plus 6, and that's all one polynomial. And then 6x squared plus 4x plus 9. That's all one polynomial. Because I'm adding, are these parentheses really necessary? Hopefully you remember that they are not. Okay? So all we have to do is we have to add like terms. Well, how do I know if it's a like term? How do I know if it's a like term of 2x squared? Well, if there's another term with an x squared. So if I have 2x squared and 6x squared, I get 8x squared. Okay? Can you see that? No? Okay. 8x squared. Okay? That came from the blue. I'll underline it with blue. How about that? Okay? Then we have 5x and 4x. Well, what is 5x and 4x? Well, that's 9x. We got that from the red. Okay? Then we have 6 and 9. Well, what is 6 and 9? That's 15. And then we're done. We combine our like terms and we get this polynomial, this resulting polynomial. Okay? One last example of adding polynomials. 3x squared plus 3x squared plus 5x minus 10 and 5x squared minus 7x minus 4. Now, so this is still adding polynomials, but we do have some negative signs in there, so we just have to be aware of those, okay? We're combining our like terms. Well, if I combine a 3x squared and a 5x squared, what do I get? 8x squared, okay? That came from the blue. What happens if I add 5x and negative 7x? Negative 2x, right? Negative 2x, okay? Again, what do I get if I add negative 10 and negative 4? Well, negative 14. Okay? Any questions? If you have some, wait till I get back and ask me then. Okay? So what about subtracting? Subtracting polynomials. Same rule applies as when we're adding. We can only add if they are like terms. We can only add if they have the same exponent. Okay? Here, these both have an exponent of x to the fifth, so we combine their coefficient. 7x to the fifth minus 4x to the fifth is going to be 3x to the fifth. Once again, we only combine the coefficient. We don't mess with the exponent. We leave the exponent alone. Okay? Subtraction is where you'll get in trouble. I don't want you to get in trouble, but if you're not careful, you will. Okay? What is being subtracted right here? What do you think? What's being subtracted? Do you notice that everything in the second parentheses is being subtracted? Every single term. Okay? So we have to remember that subtraction sign is there, or I'll show you another way we can do it here in just a second. Okay? 4x squared minus 2x squared. 4x squared minus 2x squared. Well, 4 minus 2 is 2. And again, we leave the exponent alone, so we get 2x squared. Okay? 3x minus 7x. Well, 3x minus 7x is negative 4x, right? Okay? See how we're subtracting each term? 5 minus 9. Well, 5 minus 9 is negative 4. All right? Now, that gets tricky sometimes because we are changing the sign of, aren't we changing the sign of every number? It's almost like we're distributing the negative sign to each term, isn't it? And so sometimes people will rewrite this second problem as negative 2x squared minus 7x minus 9 and then treat it like an addition problem because we already distributed that negative sign. So 4x squared plus negative 2x squared is 2x squared. 3x minus 7x is negative 4x. And 5 minus 9, 5 and negative 9 is negative 4. Okay? I don't care which way you do it. Be consistent, though, so you don't mess up. All right? So I'll do this whole problem the way that I just showed you. Okay? I'm going to distribute the negative here. So this will become a positive, this will become a negative, and this will become a positive, and then it becomes an addition problem because I distribute that negative to each one of the terms here. Okay? So now I have 3x squared and 2x squared. Well, 3x squared and 2x squared is 5x squared. Okay? 5x squared. Then I have 6x and negative 12x. Well, that's negative 6x, isn't it? 6x and a negative 12x, 6x minus 12x. Then I have a negative 10 and a positive 4. Negative 10 and positive 4. Negative 6. Okay? Any questions? Again, if you have questions, wait till I get back. I'll be back tomorrow. Okay? So we've done adding, we've done subtracting. Now, multiplying. Okay? So first of all, I gave us some little things to start with, just little individual problems. 4 times 3x squared. Well, what is 4 times 3? Those are the coefficients. I multiply those. I don't have any other variables, so I just get 12x squared. 5 times 7. Well, 5 times 7 is 35. Now we have to remember our exponent rules. Our exponent rule says if we're multiplying like bases, what do we do with the exponents? Do you remember that? When we're multiplying like bases, we add exponents. So this is x to the 6th. Because there's a 1 there and a 5 there. Okay? Multiply the coefficients like it asks you to. But then, if we're multiplying like bases, we add the exponents. Okay? So those are just some basic reminders. Let's do some actual multiplication problems now. Not that those weren't, but you know what I'm saying. Okay? What am I going to do with this 4? There's 3 terms, so it is a trinomial inside of the parentheses. So I will distribute the 4 to each term inside of the parentheses. I get 12x to the 3rd plus 20x minus 24. I didn't have any variables up here with the 4. That means this 4 has a special name. It's called a scalar multiple. It's a whole number multiple or an integer multiplier times the polynomial. Okay? So that's just my resulting polynomial from when I multiply 4 times this polynomial. Okay? What about this? This is a 2 terms, so it is a binomial. This is 2 terms, so it is a binomial. Now, a lot of you guys learned FOIL, and that was fine at the time, right? We're a little older now, so we need to call it by what its actual property is in mathematics. And this property is called the distributive property. I'm going to distribute this 4x to each term in the second parentheses, and I'm going to distribute this -1 to each term in the second parentheses. Okay? So what do I get when I multiply 4x times 3x? Well, I get 12x squared. What do I get when I multiply 4x times 5? 20x. Okay, so I took care of the 4x. Now I have the -1. What's -1 times 3x? -3x. And what's -1 times 5? -5. Now, I need to combine my like terms in order to simplify all the way. Those 2 terms are alike because they both have x's. Now this one has an x too, but it's also an x squared, so we can't combine that one. Okay, so I get 12x squared plus 17x minus 5. Done. Okay. Last example. If I have, see, this one's 2 terms, so that is a binomial. 1, 2, 3. This one's 4 terms, so we just call that a polynomial. Okay. Like I told you earlier, there's some names for those, but here at our level, Algebra 2 level, we just have monomial, binomial, trinomial, and all the rest of them are polynomials. Okay. So we have a binomial times a polynomial with 4 terms. So do you see why if we can't use FOIL on this problem? Because that's just first, outside, inside, last. We don't have that down here. So that's why it's better if we call it distributive property, because that's what's actually happening. We're going to distribute this term times each one of these terms in the second parentheses. We're going to distribute this term times each one of these terms in the second parentheses. Okay? I'm also going to write my answer. As I'm doing the problem, I'm going to write it a little different, just so you can see a different way to do it. This way was horizontally. The way to write the answer to set it up is horizontally. The way I'm going to show you next is vertically. Sometimes helps people keep track of like terms a little bit better. Okay? But it's up to you. Whatever you want to do is okay with me, as long as it's legal. Okay? 2x squared times 4x to the third. Well, 2 times 4 is 8. X squared and x to the third is x to the 5th. Okay? 2x squared times -2x squared is -4x to the 4th. We're multiplying, so we add the exponents. Okay? Now 2x squared times -7x, that gives me -14x to the third. And then 2x squared times 5 gives me plus 10x squared. Okay? So that took care of all the first term. Now let's do the second term. What's 3 times 4x to the third? Well, it's 12x to the third, right? Instead of writing it down here, I'm going to write it right here. Why do you think I'm going to write it right there? Isn't that under the term that it's like? Right here? It's easier to collect them. Okay? So then I have 3 times -2x squared. That gives me -6x squared. So you see, once again, I've lined up the like terms. 3 times -7x. Well, there's not any more like terms, so I'm going to just keep it right down here. -21x. And then 3 times 5 is 15. Now I just have to add my like terms like I did back up here when my adding polynomials notes. Okay? So I get 8x to the 5th minus 4x to the 4th minus 2x to the 3rd. Right here, plus 4x squared, and then minus 21x plus 15. Okay? Guys, remember, this is one of those things, the adding, subtracting, multiplying, and guess what we're going to do tomorrow? Dun, 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 dividing. This is kind of some skills that I have to teach you first, and then I can teach you why I'm teaching them to you, if that makes any sense. Okay? There's word problems, which I know you all love. There's word problems that we'll go through, and you'll see how this kind of skill is used. Okay? I'm going to do a couple more multiplying polynomial problems because of how they're set up. Okay? This doesn't necessarily look like a multiplication problem, but it is because of what that means. Do you guys remember what it means for something to be squared? Hopefully you remember that it means it's multiplied by itself. So another way to write this problem is 3x plus 5 times 3x plus 5. Now a lot of wrong people think, oh, that's squared. I'll square this and square that and get 9x squared plus 25, and that's the answer. And I promise you, if you do that, you'll get it wrong every time. I don't want you to get it wrong every time. So we're going to write it twice. It says squared, so we're going to write it twice. And then we just distribute, just like we did on the problems that we just did. 9x squared plus 15x plus 15x plus 25. So that the answer, the final answer I get is 9x squared plus 30x plus 25. If all you do is square the first term and square the second term, like I told you, you'll get it wrong every time because you'll have missed that middle term. Okay? So what does this one mean? 4x minus 7 cubed. If it's squared, it means I write it times itself. If it's cubed, it means I write it 3 times. 4x minus 7 times 4x minus 7 times 4x minus 7. Now, a lot of people get confused here and they want to distribute here and here and here and here. That's not quite right, though. So let's think about this for a second. If I said 2 times 4 times 5, if I made that the problem, do I say 2 times 4 and 2 times 5? Or do I say 2 times 4 is 8 and 8 times 5 is 40? That's what I do, isn't it? Multiply the first two together and get an answer and multiply that answer by the third one. Well, that's exactly what we need to do here. We need to distribute the 4x here, 16x squared, and here. So I'm just ignoring that third term for a second and just paying attention to the first two. So minus 28x plus 49. So I get 16x squared minus 56x plus 49. And then I have this other 4x minus 7 that I have to multiply. So I do the same thing that I did on this previous page with my distributive property, right down here. First term times the first term here. First term times the second term here. Middle term times the first term, middle term times the last term. Last term times the first term, last term times the last term. Okay? And then that resulting multiplication would be our final answer of this. Let's see, I have to get my calculator out to do that. I don't know some of those multiplication problems in my head. So 16 times 4 first. Okay, that's 64. So 64x to the third. And then I have 16 times 7. And that gives me minus 112x squared. I'm going to go and line mine up vertically just because for me it's easier to see. Okay? So I have negative 56 times 4. So that middle term times that first term over here, and that gives me negative 224x squared. See, I've got an x and an x, so that gives me x squared. And then I've got negative 56 times 7. So minus 392x. X here? No. Sorry. Yeah, x here, no x here. Okay? Then I do the last term. 49 times 4x, which gives me 196x, and then 49 times negative 7, which gives me negative 343. And then I combine my like terms. So 64x to the third minus 336x squared. Then we've got a negative 392 plus a 196. Oh, that's nice. Negative 196x minus 343. Now, that might look a lot messy, right? Big numbers, but relatively speaking, are they really that big? The answer is no. Just say no. Okay? Now, there's one more example on this page right here. Okay? You have some problems on your homework like this. First of all, let me remind you what this means. X plus 6 to the 5th power means I've got to do x plus 6, x plus 6, x plus 6, x plus 6, and x plus 6. I need x plus 6 5 times. 1, 2, 3, 4, 5. Okay? That seems like a lot of work. Even to me, that seems like a lot of work. Okay? There is a shortcut in your book on page 221 if you are brave enough to try it. Okay? That shortcut is called Pascal's triangle. This triangle was named after a French mathematician named Blaise Pascal. He lived in the 1600s. Okay? If you're brave enough to try it, I want you to go and see if you can figure this out with Pascal's triangle. I'll repeat the page number, page 221 in your book. Okay? I want you to make an attempt at this. Okay? Even if you're not brave enough, I still want you to try it. But we will talk about this when I get back. Don't worry about that. If it's not something that you understand right away, we will talk about it. Plus, you can always do it this way. You can always multiply each term, multiply the first two terms, multiply that by the third term. Whatever you get, multiply it by the fourth term. Whatever you get, multiply it by the fifth term, using the distributive property like we did over here. Yes, that's a lot of work, isn't it? That's why we're glad that Mr. Pascal came up with his shortcut. Okay? But like I said, we will talk about that when I get back. All right? Please behave for the sub today. They're giving of their time to be here with you since I cannot be. Just as a reminder, I am at a workshop in Abilene, and I will be back on Wednesday. I will finally be back the whole day, as far as I know, on Wednesday. Okay? I hope you guys are having a great day, and I will see you tomorrow. Bye.